So, have you ever seen a math problem that looks like this and just felt kind of overwhelmed? I get it. It looks complicated, but honestly, it's a really satisfying puzzle to solve. We're talking about and inequalities, and I'm going to show you this awesome little trick I call the sandwich method to totally master them. Here's our game plan. First, we're going to figure out what this whole inequality sandwich thing even is. Then, I'll let you in on the single most important rule you need to know. After that, we'll dive in and solve some examples. I'll point out the common traps to look out for, and then we'll wrap up by seeing where this stuff actually pops up in real life. Okay, let's get into it. Section 1, the inequalities sandwich. We need to start by understanding what makes this a new kind of puzzle, and you'll see why that sandwich name makes perfect sense. Now, over on the left, you see a basic inequality, something you've probably seen a bunch of times. X plus 2 is less than 5. Pretty simple, right? It's got one boundary. But look at the one on the right. Now, our expression x plus 2 is literally sandwiched between two numbers. It has to be bigger than 1, but at the very same time, it has to be smaller than 5. See? That's the puzzle, finding the values of x that make both of those things true. So how in the world do we figure out what x can be? Well, let's jump to section 2. This is what I call the three-sided balance rule. And I'm telling you, this is the one and only rule you need to nail these problems. Okay, so here's the big idea. Our main goal is to get x all by itself right there in the middle of the sandwich. The way we do that is by keeping everything perfectly in balance. You can almost picture a scale, but with 3 trays. Whatever you do to that middle part to isolate x, you have to do the exact same thing to the left part and the right part to keep it all level. Seriously, if you remember just one thing from all of this, make it this sentence right here. This is the golden rule. Whatever you do to the middle, you must do to the left and the right. Say it with me. Burn it into your brain. It is the key that unlocks every single one of these problems. All right, enough theory. Let's get our hands dirty and actually put this rule into practice. Section 3, solving the sandwich. Let's do this step by step. Let's start with a nice, clean problem to get warmed up. We need to solve for x, where 4 is less than x plus 3, which in turn is less than 9. Okay, time for our rule. We want x by itself in the middle. What's hanging out with it? A plus 3? So to get rid of it, we do the opposite. We subtract 3. And remember, we have to do it to all 3 parts. So on the left, 4 minus 3 gives us 1. In the middle, the plus 3 and minus 3 just cancel each other out, leaving us with our x. Perfect. And on the right, 9 minus 3 is 6. And boom, just like that, we have our answer. X is any number between 1 and 6. Okay, you ready to level up a little? Let's try a 2-step sandwich. Now, this one looks a bit more intimidating, but don't worry, the rule is exactly the same. We're solving for -5 is less than or equal to 2x minus 3, which is less than 7. Yeah, this one takes 2 steps, but the logic doesn't change. We always work from the outside in. First things first, let's get rid of that minus 3 by adding 3 to all 3 parts. So on the left, -5 plus 3 is -2. In the middle, the 3's are gone. On the right, 7 plus 3 is 10. Awesome. Now we have -2 is less than or equal to 2x, which is less than 10. We're so close. To get x all alone, we just divide everything by 2. That leaves us with our final answer. -1 is less than or equal to x, which is less than 5. See? Same rule. Okay, what if you see something like this? It looks a little weird, right? It's really just a sandwich that's been pulled apart. You've got 2 separate rolls connected by that super important word and. We need to find the numbers for x that are greater than 3 and, at the same time, less than 8. That word and is everything here. It means both of these things have to be true at once. So what numbers are bigger than 3, but also smaller than 8? Well, logically, it's all the numbers between 3 and 8, right? So we just use that simple logic to put the 2 pieces back together into the sandwich form we're used to. 3 is less than x, which is less than 8. You're doing awesome, but listen, there are a couple of really common mistakes that are super easy to make. So let's head to section 4, common traps to avoid. You don't want to do all the work just to have a simple error make your whole sandwich fall apart. Okay, these are the 2 biggest trip-ups I see all the time. First one, forgetting a side. It is so easy to focus on the middle and the right, and your brain just forgets about that left side. The second you do that, the whole thing's out of balance and the answer's going to be wrong. Remember, 3 equal parts. The second trap is an old classic. If you multiply or divide by a negative number, you have to flip the inequality sign. But in a sandwich, that means you have to flip both of them. It's so easy to forget in the middle of a problem.
Okay, so you've got the mechanics down. But I know what you might be thinking. When am I ever going to use this? Let's just tackle that question head on in our final section. Inequalities in real life.
So just picture a factory. Inside, there's this super high-tech machine, and its entire job, all day long, is to cut metal pipes to a length of exactly 10 meters. But here's the thing about the real world. Nothing is ever absolutely perfect. No machine is that precise, so there's always an acceptable tiny little range of error, we call it tolerance, and for this machine, let's say the allowable margin of error is plus or minus 0.1 meters. So what does that actually mean for the pipe that comes off the assembly line? It means its final length, we'll call it L, has to fall within a very specific range. It's okay if it's 9.9 meters, and it's okay if it's 10.1 meters, but it can't be any shorter or any longer. And would you look at that? That's a real-life inequality sandwich. This isn't some abstract math problem. This is a core principle in things like engineering and quality control. So there you have it. You now get the logic of how to solve for a variable when it's trapped between two different boundaries. And that is a really powerful tool to have. So I'll leave you with this question to chew on. We've used this logic for and inequalities. But what do you think happens when we apply this same idea, this idea of being within a certain range, to a concept like absolute value? That's a puzzle for next time.